All right, solving rational equations. So we have equations that basically have fractions, right? So, um, and the fractions have equations in them. So this is pretty interesting stuff here. So solving rational equations. So the idea is that when you have a fraction that's equal to another fraction, right? A fraction that equals a fraction. That's what we want. Because once it's in the form of a fraction equals a fraction, then we can cross multiply. And that's the whole point. Right? That's the whole point. The denominators come, so we're clearing the fraction basically. 4x plus 6, 5, 2x. Now a lot of this can be done mentally. Right? I probably could have done this mentally. 4x plus 24, 10x. And then combining like terms. X is equal to 4. So the idea is that when you come to what you think X is, right, whether it's 1x, one value, or multiple values, you always want to do a quick glance at the original problem, particularly in the denominators, and then see that if you were to plug in your answer, that you don't get 0, right? Because division by 0 is bad. It's undefined, right? So 2 times 4 is 8. That's different from 0, so we're good. And then 4 plus 6 is 10, which is, again, not 0, so we're good. So if we plug in 4 and we get 0 for any answer, it doesn't work. One technique that I kind of like is that before I even start the problem, let's just hash out what our bad values are. So left-hand side, what would make the bottom 0? Well, 0, because x, 2 times 0 would be 0. And then on the right, -6, right? Because -6 plus 6 is 0. So right away, if I solve this thing out and I get 0 or -6, I know that those are my bad answers. Well, it's not. It's equals 4, so we're good. So number 2, quick little check. The bad answers are x equals 0 and -2. So 0 and -2 are bad if that comes up. So cross multiply because it's a fraction equals a fraction. So 9x plus 2 equals 4 times 3 is 12. So 9x plus 18, 12x minus 9x. 18 is equal to 3x. X is equal to 6. And that's different from what we established in the beginning. It's not bad, right? It's not bad at all. Okay. The bad answers. +1 and -1. So x equals either one of those. It's no bueno. So cross multiply and divide because it's a fraction equals a fraction. 6x plus 1 is equal to 9x minus 1. Distribute. 6x plus 6, 9x minus 9. So minus 6x from both sides. I'm going to add 9 to both sides. So this is going to be 15 is equal to 3x, which we see that x is equal to 5. Okay, number 4, bad answers. +1. And then If it's not obvious, you can set it equal to 0, right? Because I want to know, when does that equal 0? When x is 2/3. So if x comes out to 2/3 or 1, we're going to exclude those. So fraction equals a fraction. Cross multiply. So this is going to be 8x minus 8 equals 6x minus 4. Okay. Combining like terms is the easy part. 2x minus 8 minus 4. 2x equals 4. X is equal to 2. All right, number 5. If x is negative 1, then that's bad. So this way is going to be x squared plus x. This way is going to be equals 3x plus 3. All right, moving everything left. So this is going to be x squared minus 2x minus 3 equals 0. So we can factor two numbers that make negative, multiply and make negative 3 that add up to negative 2. 1 and 3. And the big one gets the negative. So this is going to be x is equal to negative 1. X is equal to positive 3. And look, right away we see it. So we exclude the highlighted x equals negative 1. X equals 3. Okay. Our bad answers. X equals negative 5, negative 2. So going this way, x squared plus 5x. This way, not so much. Well, it's going to be x squared plus 2x minus 3x minus 6. So you could pause it, check that. And it's equals. All right, combining like terms. X squared plus 5x equals x squared minus x minus 6. Right, 2 minus 3. If we move everything to the right, so minus x squared, that's going to cancel. Minus 5x, we're going to equal negative 6x minus 6. And factoring out a number, so right, this is going to be equal to 0. This is going to be, factoring out negative 6, we're going to get x plus 1. So x is going to be equal to negative 1. Right, x equals negative 1. And that's different from our estimated zeros up top. So x equals negative 1. Oh, can't see it. Okay. First thing I notice is a difference of squares. Oh, no, it's not, because it'd be technically x minus root 2 x plus root 2. So it's not. But the bad x's are going to be 0 and technically plus or minus root 2. That ain't going to come up, I promise. That ain't coming up in this. That ain't coming up. But if some reason it does come up, well, I say promise, right? I have a feeling it might come up now that I promised it. So let's see. This is x squared. This is going to be equal to negative x squared plus 2. So then, combining like terms, plus x squared plus x squared. So this is going to be 2x squared is equal to 2. Dividing 2 out, we're going to get, where there's a 1 here, right, when it cancels. So x squared is equal to 1. Solving this thing for just x is equal to plus or minus 1. We have two answers, positive 1 and negative 1. That one was interesting. That was interesting. Okay. Let's factor the left side bottom. Two numbers that multiply to make negative 8 that add up to 2. So, negative 8 is going to be 1 and 8, 2 and 4. So I can make a 2 out of 2 and 4 for sure. So this is going to be x minus 2 plus 4, right? That makes negative 8, and then we add it together, makes positive 2. Okay, looking at this, the bad x's for the denominator are going to be positive 2, negative 4, and negative 4. Okay, so if we get one of those, we're going to exclude it. Multiply here. This is 4, x minus 2, x plus 4 equals this way. 4, x minus 4, x plus 4. All right. And I want to just start canceling things out. Right? Both sides have a 4. Both sides have an x plus 4. And really all that's left is x minus 2, x plus 2. Or x minus 2, x minus 4. So this would mean minus x, which is going to cancel. So that's already no good. So we're left with negative 2 equals negative 4. What? All right. No solution. That's no solution. That's wild. I mean, even if you're like, nah, fam, you got to work this out. So if you were to start distributing, I mean, if you distributed it all out, once you start moving like everything, all the x's to one side, things are going to start canceling for sure. For sure. So that's crazy. Okay. Well, either way, when this is a prime example of when this, because this isn't rare. This definitely happens. So No solution when it does. Don't freak out. Now, I guess this is a good topic. Let's just say, for the sake of argument, we came out and it came out to like -2, right? If when you do this and the numbers match in the end, there's infinite solutions. But when the numbers differ, there's no solution. So this is a good teaching point, I think. It's a good teaching point. All right. Number 9. All right, let's factor some things first. So 2 numbers that multiply to make 9 that add up to 3. Add up to 6. Because I was thinking 3. It's going to be 3 and 3. Negative. Right, -3 times -3 is +9. -3 plus -3 is -6. Right-hand side, I can factor out a common factor with x. So left behind is x minus 3. Okay. Looking at this, the bad answers are going to be +3, -3, nope, just +3, +3, and 0, right? Because here, 0. Okay, now that it's fully factored, see if we can simplify. So there's an x, and that's pretty much it. So when we go to cross multiply, we're going to get 9x minus 27 equals whatever this way is, 3 times x minus 3, x minus 3. All right, we're going to have to distribute. So this is going to be x squared minus 3x plus 9. So that's x squared minus 6x plus 9. Oh, I guess I knew that. And we'd have to distribute the 3. So this is going to be 3x squared minus 18x plus 27. And this is equal to 9x minus 27. I'm going to move everything towards the right. Move everything from the left to the right. So minus 9x plus 27. So 0 is equal to 3x squared minus 27x plus 54. Is that true? 54? 25, 25 plus 4. Yeah. So I can divide a 3 out of everything. But 0 divided by 3 is still 0. So this is going to be x squared minus 9x plus 3 goes into 5 once. 8. So 2 numbers that multiply to make 18 that add up to -9. 6 and 3. All right, so this is going to be x is equal to -6 and -3. But that's not right because of the -9. So they both have to be negative. I can almost hear you yelling at the screen. So this means that x is equal to 6 and x is equal to 3. Looking at our answers that are bad, X equals 3 is no good. That's no good. So x equals 6. X equals 6 is our solution. All right, number 10. Bad answers. -2, +1. This way, we're going to get 3x minus 3 is equal to 6x plus 12. Okay. Moving everything one direction. Minus 3x, minus 3x, plus 3, plus 3. I'm doing this for a very specific reason, because on the left, we're going to get 0. Then on the right-hand side, we're going to get 3x plus 15. I guess I went the wrong way. Doesn't matter. Keep going. -15. So this is going to be -15 is equal to 3x. X is equal to -5. And that doesn't match any of our excluded answers. So x is equal to -5. That's pretty ideal, right? When it's just single binomial on each side. Those are fun. Okay, 11. 11. X can't be 0 no matter what this comes out to. You know what? Okay. I just now noticed I put the slash. So x can't be 0. On all these other ones, I was saying that if x does equal those things, then the bottom will be 0. Oh, well, I'm not going to go back and fix now. You get what I'm saying, right? X can't be these numbers that I'm writing up top. So to get a common denominator, I got to multiply top and bottom by x. So that's basically going to be x squared up top. So this is going to be 4 plus x squared over x equals 5. Multiply both sides by x. Right, or if we stick to what we've been doing, 5x, right, that's the same thing. So left-hand side, however you want to look at it, the x's cancel. Whatever the case is, 4 plus x squared is on the left. 5x is on the right. That's what it is. Subtracting 5x from both sides and writing this in descending order, we're going to get x squared minus 5x plus 4 equals 0. So two numbers that multiply to make 4 that add up to -5. 1 and 4. And they both have to be negative. Therefore, x is going to equal 1 and 4. And neither one of those are 0, so we're good. Those are the solutions. Okay. Number 12. We're cooking. So, common denominator. Technically, first things first, x can't be 0. So anything other than 0, we're good. Our common denominator. Okay, I'm going to multiply the right-hand side by x, top and bottom. Multiply the left side by 2, top and bottom. So this is going to be 4 plus x over 6x equals 4 over 3x. Okay. We can cross multiply. Nothing wrong with that. I'm noticing that if I multiply this side by 2, then I'm going to force this to be 8, 6x, right? Because 2 times 3 is 6. And now, because the denominators match, I no longer care about the denominators, right? I can simply set the numerators equal to one another, and that's going to get us what we want. So 4 plus x is equal to 8. And this is going to be minus 4. So x is equal to 4, which is different from 0. So we're good. So yes. So you always got to think, be on the lookout for if you can make the denominators match, right? Whenever the denominators, when you have an equation, when the denominators equal each other, it's so nice because then you can just start saying things equal to each other, particularly the numerators. So if you didn't, you'd end up with like 24x is equal to 12x plus 3x squared which would be this. And look, x is either 0, but x can't be 0. So we're almost like excluding the bad one. And then x would be positive 4. So, I mean, in the end, it's going to work out. Like, it's designed that way, right? Like, somehow it just works out. It's the beauty of it. Okay, 13. Common denominator right away. X over x. So 5 minus 2x over x equals 2x plus 3. So right away, x can't be 0 nor negative 3. So 2x equals 5 minus 2x, x plus 3. I feel like this is where it starts to get rough. So this is going to be 5x plus 15 minus 2x squared minus 6x. Combining like terms on the right, we have negative 2x squared minus x plus 15. So subtracting 2x from both sides, we're going to get negative 2x squared minus 3x plus 15. Okay, so let's see if this can be factored. Let's see. Can't factor anything out. Technically, I could factor out a negative to make the math kind of easy. If we factor out a negative, it turns the leading term positive. So slide and divide method will give us x squared plus 3x minus 30. So negative 30, what two numbers that add up to 3 or somehow make a 3? Not 4 and 15. 4 and nothing. 5 and 6. Anyway, can I make a 3? Nope. Okay, so can't factor it mentally. You can't factor it by looking at it. You can't use other little methods. Quadratic formula is the last way to go. So just double checking the math real quick. 5, 15, -2, +6. No, -6. Okay. All right, so this is going to be minus b plus or minus b squared minus 4 times a times c. That's not nice at all. 2 times a. Okay. -3 plus or minus 9 plus 120, right? Because 2 times 15 is 30. 30 times 4 is 120 over 4. So 129. I don't think that's a perfect square. That doesn't ring a bell. Okay, there are my two answers. Neither one of those are 0 or -3. So both of these would work. Okay, bad answers are going to be 0, -7. All right, so let's see. This one's going to take some work for sure. So x plus 7. I'm going to multiply each term by the other denominator, top and bottom. So x plus 7, x plus 7. 2x, 2x. So this is going to be x plus 7 on top, plus 6x, all over 2x, x plus 7. So combining like terms in the top is all addition, so it's going to be 7x plus 7. Bottom is going to be 2x, x plus 7. We could factor something out of the top if we wanted. 7x plus 1, 2x, x plus 7. All right. This is going to equal what's over here? -1 over x. All right. So from here, since we got a common denominator, this is basically where we say, okay, cross multiply everything. So first we're going to have 7x, x plus 1. I'm not distributing just yet. Equals -2x, 7x plus 7. All right, now we can distribute and combine like terms. This is going to be 7x squared plus 7x. This is going to be -2x squared minus 14x. Combining like terms, moving everything to the left, we're going to get 9x squared plus 14 plus 14, that's 21x equals 0. So if I factor out an x, if I factor out a 3x, I'm going to leave behind a 3x plus 7. And now if you set each of those equal to 0, right? X is equal to 0 or X is equal to negative 7/3. What were our bad numbers? 0 and negative 7. So right away, this one's no good, right? So X equals 7, negative 7/3 is good. It is good. It's all good. That's what that means. What that means. Okay. How much more we got? All right. We're more than halfway. That's the good news. Okay. Number 15. Common denominator. X minus 2 plus 2. So I'm going to X minus 2, X minus 2. This equals 3X, X plus 2. So combining on the left, we're going to get 1 plus 2, X minus 2 over X minus 2. All right. How do we want to proceed? We could either, let's just stick to what we've been doing. Multiply this. All right. First off, X can't be 2 or negative 2. Let's just throw that out there. So this is going to be what if we do some simplification first? This is going to be 2X minus 4 plus 1. So this is going to be 2X minus 3. Right, this is going to be 2X minus 3. 2X minus 3. So then this is going to be X plus 2, 2X minus 3, which is equal to 3X, X minus 2. So distributing 2X squared minus 3X plus 4X minus 6, which is going to be 2X squared plus X minus 6, which is equal to 3X squared minus 6X. Oh, you can't see it. Okay. Move everything left. Move everything left. So negative X squared plus 7X minus 6 equals 0. I'm going to divide everything by negative because I want my A term to be positive. So I'm just going to flip the signs of everything. Okay, two numbers that multiply to make 6 that add up to negative 7. Negative 1 and negative 6. Which means X is equal to 1 and X is equal to 6. Or X is equal to 6. That doesn't match either one of our bad terms, so these are good. Good to go. All right, 16. I'm factoring the left side just out of habit. So this is going to be 2 and 3. So X minus 2, X plus 3. Right, negative 6 add up to 1. Okay. So that's the left-hand side of the equal sign. Right-hand side of the equal sign. Okay, this is going to be, so 2 plus X minus 3, X minus 2. So I'm going to have to x minus 2, x minus 2. Get a common denominator on the right. And coincidentally, this is all right. That's not the numerator. That's not the numerator. So okay, right hand side. X minus 2 plus x minus 3 over x minus 2. Right, we combine it into one denominator. Distributing, we're going to get 2x minus 4 plus x minus 3 over x minus 2. Left hand side is just along for the ride. Right, 5 x minus 2 x plus 3. All right. In the numerator, let's simplify, combine like terms here. So this is going to be 3x minus 7 x minus 2. Okay, I think cross multiply time now. Or let's look at our bad answers real quick. If x is 2, negative 3, or positive. So x equals 2 and x equals negative 3. Those are our bad ones. That makes the denominator 0. So we want to exclude those if those come up. All right. X minus 2 and 5. So 5x minus 10 is equal to these three right here. So 3x minus 7, x minus 2, x minus 3. Okay. Let's just start. So I know that, so this came from x squared plus x minus 6, right? That's because we took it apart originally just to put it back together. 3x minus 7. So I'm going to distribute every term to every term in the second one. Every term in the first, every term in the second. So this is going to be 3x cubed plus 3x squared minus 18x. This is minus 7x squared minus 7x plus 42 plus 42. 5x minus 10 on the left. All right. Combining like terms, let's get it. So this is going to be 3x cubed. Where my x squared is at? There's 2. So 3 minus 7 minus 4. Just the x's. So 5x. Right, technically it's on the left side. I'm not going to forget about it. Negative 25 x and then the coefficient plus 42 and then minus 10 on the left. Okay, we're almost there. We're going to minus 5x from both sides and add 10 to both sides. Minus 5x plus 10. So maybe final answer, negative 30x plus 52. 52. All right, I'm thinking ahead, factor by grouping, but I can already tell you that I don't think it's going to match. Right, 3x minus 4 is what needs to show up on the right-hand side. I'm just thinking out loud ahead. 42 minus 10 Yeah. So I don't think it's gonna work. Because 30 and 52, the only thing you can take out is a 2. So it's gonna be 15 and 26. Yeah, nothing. So I think that's it. But that's wild though, because we need to get x equals something. Let me think about this one. Let's think about this real quick. X minus 2, 2x minus 4, plus x minus 3, negative 4, negative 3. Knew I should have went with my first instinct. So 4x squared, 18 plus 7, definitely 25. That's crazy. And that 52 is messing everything up. Right? Because what I'm looking at is that x squared, 3x minus 4. Negative 2 would be 15. Right? Because if I wanted a 3, that means I'd have to factor out a 10 to make 3x. But then you can't pull a 10 out of a 52. Right? It's not working. Okay. Do I admit defeat? All right, my first instinct. My first instinct was to do this. And because the denominators match, I don't care about that any longer. So 5 is equal to 4x minus, no, 2x minus 4 plus x minus 3, x minus 3. So then combining like terms, this is going to be 3x minus 7, x minus 3, which is basically distributing 3x squared minus 9x minus 7x plus 21. Which comes out to this, which is a lot nicer than what we had a minute ago. I feel that this can be factored. 16 times 3 is what? 16, 32, 42, 48. So slide and divide method. So two numbers that make 48 that add up to 26. Two and 24. That was a lot faster than I thought. So 2 and 24. But they both need to be negative. So x is equal to 2 and x is equal to 24, which is x equals 2 is no good. So x equals 24. Man, I don't know what I was talking about in the first half of this problem prior to us erasing, but should trusted my first instincts. I wanted to do this method to begin with, but I shied away from it. Okay, so comment about this one for sure. Okay, let's keep it moving. We're almost there. We only got like 2 more pages. Oh, okay. So the bad answers: x equals 0 and negative 6. Okay, let's just start. X plus 1, x plus 6, plus 1 over x. Gotta get a common denominator first. So x plus 6, x. So we're gonna get x plus 6, all under x squared plus x. I'm distributing mentally now, plus x plus 6. And that's, so combining like terms, we're actually going to get x squared plus 2x plus 6. That's combining the x's. Okay, so left-hand side, we have x squared plus 2x plus 6. That's, I'm just transferring the information left. This is going to equal what's on the right. 2x plus 1, x plus 6. Okay, so looking here. Right. So kind of like bringing a lesson learned from the last problem. If we just start right away cross multiplying and dividing, I feel like we're gonna run into a lot of mess. So I'm gonna get a common denominator now. And now, because this is true, right? Like we're saying that these are equal to each other. I don't care about the denominator because the denominators match, right? That's right. Like if you think about it, right? Something over 3 is equal to something over 3, but 4 is over here, right? Like, do I care? Like, if I'm solving for what x is, do I care about the denominator? No, I don't care about 3 at all. Like, x is going to equal to 4, right? I'm only looking at the numerators. That's my idea, right? My train of thought. I feel like it's flawed, but it seems to be working. So x squared plus 2x plus 6 is equal to 2x squared plus x. If I move everything left, I don't want to move everything left because that's going to make a negative x squared. Let's move everything right. So 0 is equal to x squared minus x minus 6. So two numbers that multiply to make negative 6 that add up to 1, negative 1. So 2 and 3. but the big one's negative, which means x equals -2 or x is equal to +3. Looking at our bad answers, oh, we didn't have, oh yeah, we did. So 0 and -6. So -2 and 3 are legit. All right. I mean, these are killer. So 2x minus 3 plus 1 over x. Same thing, right? Same idea. Same idea. Professional. So then this is going to be 2x plus x minus 3, right? Over x minus 3. You're just combining the numerators. So this is going to be 2 plus x is going to, or 2x plus x is 3x minus 3 over x minus 3. And that was the left-hand side, right? That was strictly working this piece. This is equal to x minus 1, x minus 3. X minus 1 over x minus 3. Same idea. Right, making the denominators match. So I don't care about those anymore. Right, they don't cancel each other out. I'm just simply saying that I don't care about them. Right, like, so it's not like they cancel. That's not what's happening. It's just, I'm disregarding. Okay, 3x minus 3, x squared minus x. Minus 3x, minus 3x, plus 3, plus 3. So 0 is equal to x squared minus 3x plus 3. Two numbers that multiply to make 3 that add up to 3. Nothing. Hold on, I'm thinking. Hold on. So let's back up. Let's back them up. All right. I do notice that we can factor out a 3, x minus 1, x minus 1. So what this is saying is that 3 x minus 1 is equal to x minus 1 x. If I factor out the x minus 1, x equals 3. But I don't like the fact that we only get one answer. So the bad answers here, x equals 0 or positive 3. So 0 or positive 3 are bad. Well, x equals positive 3 is bad. So I wonder, what was it? X squared minus 3x plus 3. Is that what it was? I don't remember. So this was 3x minus 3. So we know that that doesn't work. X equals 3 doesn't work. X squared minus, oh no, it was a 2. It was 2. Right, it was 2. So minus, Because when oh no, it's changing now. It's changing on me. Does that mean I made a mistake before? Did I make a mistake now? So 3x minus 3 is equal to x minus 1 times x squared x. So if I minus 3x plus 3 plus 3, 0 is equal to x squared minus 4x plus 3. Oh, I made a mistake before. Okay. Well, this changes everything. This changes everything. This is going to be, so two numbers that make 3 that add up to negative 4. So this is going to be negative 3 and negative 1. Well, we know that x equals 3 is bad. So x equals 1. X equals 1 is the answer. Wow. What? That was a adding mistake? I don't even know what I did. Whatever. We're there now. X equals 1. So hopefully you can follow what I did there the second time before I erased. All right. Okay. Yo, these problems are relentless. All right. I ain't scared. Okay, let's get it. So this is going to be 6x. X plus 4. Plus 4. Get my common denominator now. X plus 4. X plus 4. This is going to be 6x plus 4x plus 16 over x plus 4. Combining like terms, that's going to be 10x. Right, 6 plus 4 is 10x. So 10x plus 16 over x plus 4. Equals the right hand side. 2x plus 2, x minus 1. Okay, first off, bad answers. Negative 4 and 1. Positive 1. So negative 4 and 1 are bad. Nothing can cancel. Can't do any tricks. So let's just see what happens. Things can factor out, but I don't want to factor things out and then put it back in later. Like, I don't know. It's just seems like a lot. Because what I'm saying is this could be 2x plus 8 if I wanted. No, it can't be that. See, I don't want to factor nothing out. It would be 5x. Actually, technically, it'd be 5x. I don't want to do that. So let's just do 10x plus 16 x minus 1 is equal to this way. X plus 4, 2x plus 2. Okay, let's just start distributing. So this is going to be 10x squared minus 10x plus 16x minus 16. Right hand side. 2x squared plus 2x plus 8x plus 8. This is looking better. Combining the like terms. 10x squared plus 6x minus 16 is equal to 2x squared plus 10x plus 8. All right, I'm going to move everything left. So 8x squared minus 4x minus 24 equals 0. I can divide a 4 out of everything. So this is going to be 2x squared minus x minus 12 minus, 6 equals 0. Okay. So slide and divide, right? This is going to be x squared minus x minus 12. So two numbers that make negative 12 that add up to negative 4. Add negative 1, which is 3 and 4. So 3 and 4. But the big one needs to be negative, so this is going to be positive. All right, so here's the deal. Because we multiplied the slide and divide method, we have to divide that out. And I think I missed this in the last problem, now that I'm thinking about it. So this is going to be x minus 2, right, because this is 2. So x is equal to 2, or x is equal to negative 3 over 2. What are our answers? Negative 4 and 1, those were bad. So So 2 and negative 3/2. Let me just check real quick. I know we did slide and divide somewhere, and I feel like I didn't do that. Yep, right here. Dang. All right, so if we divide by 3, that's going to mean x is equal to 2/3. X is equal to 8. So here, both of these were correct. That's wild. Okay, moving right along. Moving right along. First off, x can't be 0 or 4. All right. 10 plus 3x over x. All right, I'm thinking x squared plus 9x is equal to whatever this is. X minus 4, 10 plus 3x. So 10x, 3x squared, negative 40, negative 12x. So like terms, negative 2x, negative 40, x squared plus 9x. minus x squared minus 9x. This is going to be 2x squared minus 11x minus 40. All right. Can't do it mentally. Quadratic formula would be the thing here. So negative 11. It's already negative, so positive. Plus or minus 11 squared. 121. Negative 11 squared. Minus 4 times A, which is 2 times C, which is negative 40. All over 2 times A. So we have 11 plus or minus. What is this? 121 plus 8 times 40. 8 times 3 is, so 320 over 4, which is 11 plus or minus 441 over 4. Either one of those doesn't equal 0 or 4. Man, they're not coming out clean at all. What's up? Okay, we're almost done. 3 left. Let's finish strong. Okay. First thing I notice is I can pull out an x. X minus 3. Which is nice as far as common denominator, because I can put in an x top and bottom. So this is going to be 18 minus 6x over x, x minus 3. And this is equal to 5 over x. Okay. Bad numbers. X can't be 0. X can't be 3. All right. What do I want to do? I think x minus 3, x minus 3. So then this is going to be 18 minus 6x, 5x minus 15. So 11x. $33. X is equal to 3. X is equal to 3. All right, can't have 3. Can't be 3. So what does that mean? That means, did we miss an answer somewhere? What if what would this do? Oops. That's even worse. But there are two answers there. That's crazy. So because this would be 15x. That's why. Okay. Then that would mean I was right the first time. So this would be minus 33x equals 0. That's what it would be. And it comes out to dividing both sides by 11. X squared is equal to x. No, 3x. Which if I divide by x, right, x can't be 0, I already know that. X is equal to 3, okay. No, we were right. Gotta trust the math on that one, I guess. It's just seems weird. X minus 3, or x is equal to 3. But x can equal 3, because that's what we established in the beginning. So, no solution. All right. Okay. 22. Same thing, right? Let's go. X plus 3, x minus 3. X minus 5. Common denominator. Looking at the other denominator. X minus 3, x minus 5. All right, combining, we're going to get x minus 5, x plus 3. X minus 3. All over x minus 5, x minus 3. All right, we know that this is going to be equal to x minus 5, x plus 5. So that means I'm going to hit this side, x minus 3, right, to make the denominators match. So, looking at just the numerators, x minus 5, x plus 3, plus x minus 3. This should equal x plus 5, x minus 3. All right, we're going to expand it all out, combine like terms, and then factor in the end. So x squared plus 3x minus 5x minus 15 plus x squared minus 3x. This is going to equal x squared minus 3x plus 5x minus 15. All right, combining terms on the left. So x squared and x squared, 2x squared. 3x and 3x is going to cancel. So minus 5x minus 15 equals, right-hand side, x squared, these two combined, plus 2x minus 15. All right, minus x squared minus 2x plus 15. Minus x squared minus 2x plus 15. So right-hand side is 0. Left-hand side cancels. X squared minus 7x equals 0. So I guess starting off, x can't be 3 or 5. So this is going to be, I can factor out an x minus 7 equals 0. So either x is 0 or x is equal to 7. What were our two numbers? 3 and 5. So I'll stand by these two. 0 and 7. All right. Last question. Last calculating question. Okay. Bottom right. Numbers that multiply to make -3 that add up to -2. 3 and 1. So -3, +1. Okay. Right hand side. X plus 1. Top and bottom. So now that they match. Yep, they do. Is going to be x plus 1 is equal to 1. So let's just look at x can't be 3 or -1. All right, distribute. 2x plus 2 is equal to 1. Minus 2, minus 2. $2x is equal to -1. So x is equal to -1/2. Okay. That's the last calculating question. Here's some theory type stuff. Describe and correct the error in the first step of solving the equation. So what did they do? I don't know what they did. Well, see, what I would have done? So this would have been 2x plus 4x squared. So then this would have been x over x. This would have been 2 over 2. So then 3x over 2x squared plus 8 over 2x squared. So what did they do? They didn't do this. They didn't do that. It looks like they multiplied. I don't know what they did, but this would have been my first step. Or that would have been my first step. I don't even know how to correct it. All right, again, this would have been 5 over x plus 23 over 6. All right, my first step would have been x over x, 6 over 6. Then this would have been 30 over 6x plus 23x is equal to 45 over x. That would have been my first step. That would have been my first step. All right, hopefully this is correct.